So now that we've covered the basic features in CompletableFuture, let's turn our attention to the first of the 4 advanced groupings of features, starting with factory methods. And so that's what we're going to cover here first. Factory methods are used to initiate asynchronous computations in the context of the Java CompletableFutures API. In general, a factory method is something that creates an object. And we use factory methods from the good old Gang of 4 book, shown at the link at the bottom of the slide, in order to be able to decouple the creation of something from its use. Why do we do that? Because creating stuff is often ugly, but using it can be much simpler. And the analogy we always like to throw out there is legislation and sausage. You may not necessarily want to know how either of them is made. You may not necessarily want to deal with the consequences of them either, especially if you don't like to eat meat. But the point is that creation is different from use. And so factory methods encapsulate creation. So there are 4 factory methods that initiate asynchronous computations and shield the users from all the complexities of what is actually happening underneath the hood. These computations may or may not return a value depending on which grouping or subgrouping of these methods you happen to pick. One of the groupings is called the supply async grouping. And this allows 2-way calls using a supplier lambda or a supplier method reference. And as you can see here, there's 2 different variants of the supply async family of factory methods. The first one, which we show up here, takes a supplier, returns a completable future that, when triggered after it completes, will have the results of the supplier. And it asynchronously runs the supplier in the Java common fork join pool, which is the same pool that's used, for example, by the parallel streams framework. The second of these is similar, except you have a second parameter passed. And that second parameter, as you can see here, is the executor. And what this does is it will asynchronously run the supplier in the given executor context. So you typically would have a different pool of threads. I guess you could have one thread, but that would kind of be silly. But it'll run it in the context of the executor. So you can customize where the computations take place. And that's a little different and a little bit more powerful than what you get out of the box with Java parallel streams, because they pretty much limit you to using the common fork join pool, unless you do very, very heroic things. Let's take a look how you could actually use this in practice. One interesting thing to note here is that parameters can be passed when you invoke supply async. As you can see here, we have some parameters defined up here as strings f1 and f2. And inside the supplier lambda, you can see we use f1 and f2. And this example comes from my EX8 project in my Java 8 folder in my live lessons GitHub repository. The way this works is f1 and f2 are known as effectively final objects. And that's just a fancy name for saying that between the point where the objects are initialized, which is outside the scope of this lambda, and where they're actually used, they're not reassigned. So even though these are not explicitly defined as final variables, they're effectively final because they don't change from where they're initialized to where they're used. Supply async returns a value. And you can see here what it does is it's going to multiply bf1 by bf2, and that will be what's returned when the computation is finished. Run async enables one-way calls by passing in a runnable. What's the main difference between a supplier and a runnable? A supplier returns a result, whereas a runnable does not. So neither of them take any parameters, although we can pass them using effectively final techniques we just talked about. But runnables don't return results. As you can see here, there's 2 of these. They're very much akin to what we saw before with supply async. They take runnables. They return a completable future with a result of void. I use return in air quotes because it's not really returning a value. It's just saying the computation has finished. That's the only information you get from the run async method calls. And the first one up here asynchronously runs runnable in the common fork join pool, and the second one runs the runnable in the context of the executor pool or the executor, whatever the executor is connected to. Let's take a quick look at how you could use the runnable version, the run async version, Once again, you can pass parameters using the effectively final technique we talked about before. That doesn't change. Notice that there is no return value, so we have to put void with a capital V. That's the syntactic way in Java that you can have some generic parameter that indicates there is no return value. So it doesn't return anything that's useful. It just says it's done. Something is done, but we don't know exactly what happened. And as a consequence, if you have any side effects that are necessary when you call run async, you're going to have them done using some other means of output. So if you want this thing to do some kind of output, it's got to do it through a side effect. So you can see here what we do is we use system.out.println to print the results of multiplying BigFraction 1 and BigFraction 2 and turning it into a mixed string. Now, is that a good idea? Maybe not. So my recommendation for run async is don't use it unless what you're doing here is maybe at the end of some kind of asynchronous operation, it's going to return a result back to a client. This is just too brittle and too hard-coded, and side effects in general have unintended consequences we may not necessarily like. So in practice, supply async is more common and more popular than run async because it gives a result back. And that's usually what we want to do. And we also usually want to chain all these results together in a fluent style. For both these groups of APIs, the asynchronous functionality runs in a thread pool, and that, of course, helps to make the program more elastic, which is one of those reactive programming principles. The main difference is that two of them don't take a second parameter, and therefore they use the common fork join pool by default, which is fine. And the other ones take an executor, which can decide some other pool, which could be a built-in pool like a cached thread pool or a fixed-size thread pool. It could be a custom thread pool. It could be a different fork join pool that's not the common one, et cetera, et cetera, et cetera. And as I mentioned before, Java parallel streams are really designed to use the common fork join pool. There's ways to get around that, but they're not recommended and they're not portable over time. So that's the end of the overview of Java CompletableFuture's factory methods. And as you can see, they're what's used to start the ball rolling. They initiate the asynchronous computation.